Hello everyone, welcome back. Today I want to talk about the speed time graph.
So we have the speed in the y-axis and time in the x-axis.
So the straight line that runs from the origin upwards is constant. The one that is parallel to the x-axis is 0. And we have the one that is curving downwards slowly, that one having decreasing speed, and the curve that goes upwards is increasing speed. Now we have an equation to find acceleration. That is, acceleration is final velocity minus initial velocity all over time. Now the other equation is to find distance, but here the distance is found by the area under the graph. We'll talk about more of this later.
Now let's find acceleration in a speed time graph. So we have this straight line that is going from the origin, and if you want to find acceleration for this one, we can draw a line straight down to the time, and then so that we can label our time, and we can also draw another line to the part where it's labeled speed, so that we can find our v and u, the initial and final velocity. So there's that, and then so v, u, and t, the whole of the x-axis labeled t. So now when we have the equation being, oh yeah, remember that acceleration is represented by the gradient. So finding the gradient of this line will be the same thing as finding acceleration. Since we're going to use the formula a equal to v minus u all over t, so therefore I labeled it like that. It's v minus u over t. So what we should remember is acceleration is represented by the gradient in a speed time graph. And for this straight line that is parallel to the x-axis, it does not have any difference in y according to finding gradient of a straight line. So v minus u is 0. 0 divided by anything is 0. So therefore acceleration is 0 meters per second squared. Alright, and remember this, that means to the power of 2. Alright, yeah. Now here we have curves that one having curving downwards and curving upwards. So if you want to find acceleration at any given point, let's say at that point, we have to draw a tangent. From our maths, we have to draw a tangent to find the gradient at that particular point. So when I draw that tangent right there, it's perfect. Alright, and then I label the tangents part. You can see that I've labeled the t, the v, and the u, and therefore use the formula again and find my answer. Here we also do the same thing. Draw the tangent at that point. Now you see our tangent is going to touch the x-axis, meaning our u will be 0. So when our u is 0, that means we can just say acceleration is v over t. Let me just write it down. Okay, yeah, let's just label this part first. That's that. And v will be right there. Okay, so that you do not okay, just please don't mind that. Alright, yeah. Okay, let me just do this. There. Yeah. Okay, let me label that as 1 so that you don't get confused. That's there. And then okay, let me not label the other one. It's v acceleration being v minus v over t, sorry, v divided by t. Okay, and that's the end of finding acceleration in a speed time graph. Now let's find distance in a speed time graph. If you remember from the first page, we said that speed in a speed time graph, distance is area under the graph. Okay, so here we have to find distance by drawing a shape. In this case, it's going to be a triangle, as it is starting from the origin and going straight up. So the distance is going to be found by the area of this triangle, rather. So distance is half base times height, as you know. Okay, so for understanding, let me label the base. That's that. So the base is the x-axis or the time, and the height will be the perpendicular height, which will be found by that speed there. And so that's the part we need to find. All right. Yeah. Okay. Now let's go on to this next shape. Now let's find distance with a different shape. This one in the middle. Okay. Yeah. So the one that's starting in the middle is our u, initial velocity, and that will be our final velocity v. Now let's complete the shape by drawing down to the x-axis. So on our left hand side we have one parallel side, and on the right hand side of the other parallel side, this is a trapezium. So to form a trapezium, we have to find the area of the trapezium in order to find the distance. As you can see, there is the right angle there, and there is that slanting height and the two parallel sides. So distance will be half a plus b h. A and b being the parallel sides, and h the perpendicular height, which is marked with the right angle sign. That is in this case the x-axis. Okay, right there. Yeah, from there to there, and that being u, and that being b. Okay, a and b. Now we go into a situation like this. The speed constantly increased till one point it went down again till being 0. So if we are to find distance in this kind of situation, it is a composite shape. So what we do, we break it down into two or more shapes that we know and that are easy for us. So here we have A and B, A being a trapezium and B being a triangle. So the sum of their areas will be our distance. So therefore distance will be A plus B. Okay, as I said. So then that will be area of A is half AB H. Half A plus BH. Sorry. Okay, let me use the square bracket so that it's much easier to see. So that you do not confuse. Okay, there you go. Half A plus B H close square bracket plus half base times height. Okay, yeah. So then that will definitely give us our distance, as this is a composite shape. Okay, yeah. Now let's go on.
Now here we have this question. Find acceleration at t equal to 30 seconds. So let's start with that one first. So let's read the graphing. So there are 5, 1, 2, 3, 4, 5 representing 20. So each must be representing 4 units. So 4, 8, 12, 16, 20. So if you continue from there, 20, 28, 32. So between 28 and 32, 30 is there. So then that's the mark. Then if you go up at that point, so when t is 30, speed is being touched at 15 meters per second. As you can see that the first part of this graph is a curve, as it is curving that way. We have to give a tangent, right, in order to find the acceleration. So when I'm doing that, let me just choose, let me just get the color, yeah, and then let's draw that just there, yeah, let me just extend it till x being 0 so it's much easier to use. Okay, so done. So we already have 1 point, x is 30 and y being 15. Remember, your finding gradient of a curve maths says y2 minus y1 over x2 minus x1 of the tangent, right? Basically finding gradient of the tangent. So when you have that 30 and 15, we can see that when t is 0, y is 5, so we'll use those 2 points. So at t equal to 30 seconds, acceleration will be colon, yeah, just there. Let me just expand the box. Yeah. Okay. So acceleration will be, v minus u all over time. So that will be v, the final velocity. Sorry, I've chosen 15 because we chose the 2 points, 15 and 0, 5, right? If you know how to read your graphs, because you start with the x coordinate and then the y coordinate. So x coordinate is 30 and y coordinate is 15. The y is representing speed, so 15 and 5 are this thing, and that's our t from 0 till there, and u and v is 15 and 5. Okay, so when I'll write that down, it will be 15 minus 5 all over 30, right? Okay, so then 15 minus 5, 10 over 30 will be 1 over 3, be 0.33, approximately 0.33 meters per second squared, to 2 decimal places, that is. Okay, so okay, wait, let me label this. This is number 1. Okay, yeah. So now let's move on to number 2. Number 2 says find distance covered between t 120 seconds and t 160 seconds. So let's find t 120 seconds and t 160. So 160 is the last part and 120 just starting there. Okay, so we remember that we have to find area under the graph. So let's draw the shape from there. So that'll be that. So you can see that this is actually a trapezium. Alright, as we have A and B, the parallel sides on our left and right hand side, the perpendicular height just below there. Okay, let me just color the shape. Okay, so if you want to see that this is actually gonna be a trapezium, I can actually rotate it for you, but for now let's leave it. So distance will be half A plus B H. Oh, sorry, A plus B H. Okay, so which will be half A can be our left hand side, which will be 30. 30, right? So then just there, let me just draw it, so a line so that it's easy for you guys to see. That's 30 there, and this one is the 160. What this lined up with 160, it's touching 20. So A will be 30, B will be 20. So 30 plus 20, 30 plus 20 times height. Now our height is gonna be the difference in our time. So it's 160 minus 120, which is 40, as that's our height there. Okay, wait, if you turn it around, you can actually have a clue of it being a trapezium. Okay. Yeah, right. Okay. So then our time. Let's move on to the question answering part. Sorry. So that's h is 40. So 30 plus 20 is 50. Half of that is 25. So it will be 25 times 40, which will be, okay, let's write down slow, sorry that, which will be 1,000 meters per meters, sorry, 1,000 meters, which is the same as 1 kilometer. So since we're given as like our speed in meters, therefore I left it like that. Okay, so in the speed time graph, in summary, if your curve, if your graph is a curve, you draw a tangent to find your acceleration, and when you gotta find distance, you gotta find area under the graph. Okay, luckily here we're told to find area under the graph when it was a straight line on top. Do check the description box below. Okay, goodbye. Thanks for watching. Stay safe.